Good day, students, and happy last day of class before common assessments. Hooray! First of all, I'd like to thank Ms. Lewis for allowing us to have this time in seminar to work on some chemistry stuff, so hopefully we can get a lot done in this class period. Remember today that you only have 2 class periods of chemistry today. You have your time during seminar and you have my chemistry class today. So please make sure that you're working hard to minimize the time that you have to work outside of class. Remember that you guys are the best chemistry students that I've taught in 3 years and that you have learned a lot of this stuff, and these videos and the time in my class is just meant to help remind you of the things that we've already learned this year. You still have 2 days to improve and practice on your chemistry. You'll have the chemistry common assessment on Wednesday. It's actually the last common assessment that you'll take this year, so you have a little bit of time to study as well if you feel a little underprepared. If you're not taking Spanish common assessment and you don't have a double math, and you're not taking a world history common assessment because you already took the AP test, you'll have study hall during that time. So that's another 90 minutes that you will be able to work on chemistry stuff or for other classes. I will have tutorials today after school if you'd like to work on some more practice problems, but I'm expecting it to be kind of exclusive, so let me know if you're going to come. All right, please turn to page 22 in the packet provided for you. All right, I assume that all of you have turned to page 22 now. We're looking at question 1 where it's talking about, it says how many protons, electrons, and neutrons does an atom with an atomic number 92 and atomic mass number 235 contain? Well, the first thing you need to do is break down what each of these things mean. The atomic number, if you look it up, it's always the same as the number of protons. So if we look at our answer choices and we know the atomic number is 92, we can get rid of question A right away. All right, so now we have to look at what the mass number is. Well, the mass number is always the protons plus the neutrons. And if we call neutrons x and we solve for x, that means there must be 143 neutrons. So all I did there was subtract 92 from 235. So if I look at my answer choices, I can see that B is gone and now C is gone. And now I'm only picking between 2 options. The last part is to figure out how many electrons there are. You can use the charge to do this, but in this case there's no charge. So if charge is 0, then the protons is equal to the number of electrons. And so now we can see that E is the obvious answer choice based on that. So I'll just give you a second to write down any of this information that you feel is important, and then we'll move on to the next question. If you need to just talk quietly to a partner to kind of refresh your memory during this time, that's fine. So I'll give you 10 seconds starting now. All right, moving on to the next question. Look at question 2 on page 22. It's just below question 1. It's asking which of the following contains the greatest number of electrons. I've seen a lot of students struggle with these types of problems, but they're fairly simple if you can understand a couple things. First, if the charge is positive, then the atom must have more protons. Protons are positive. If there's more of them, they must be positive. If the charge is negative, then the atom has more electrons. So if it's negative, then it must have more electrons than protons. Now that doesn't mean the most negative one is always the one with the greatest number of electrons. So let's take a look at each of these. For aluminum, we have 13 protons and 10 electrons. Aluminum has 13 protons all the time. That's what makes it an aluminum. Because the charge is plus 3, it must have 3 more protons than electrons. So we must have 10 electrons. For phosphorus, it's always going to have 15 protons. That's what identifies it. If the charge is plus 2, then you must have 13 electrons because the charge says you have 2 more protons than electrons. Chlorine is neutral, so it has the same number of protons and electrons. Silicon is a charge of -1, so it has 1 more electron than protons. And sulfur has a charge of -2, so it has 2 more electrons than the number of protons. So if we look at that little number that we have put there, sulfur is the clear choice for the number of electrons. It won't always be the one that's the most negative, but in this case it is. But you can see chlorine here. It's pretty close, and it was neutral. So you should just go ahead and do each one to make sure. Okay. Question number 9 on page 24. So I'll give you 10 seconds to flip to page 24. All right, hopefully that's enough time. So we'll look at question 9 here. I like this question because it tells us a lot about what some common misconceptions are about atomic mass and where students mix up atomic mass and atomic number. So it says, what does the following image from the periodic table tell you about the chlorine? And you can see over here the image is just the image of chlorine on the periodic table. Well, there's a couple of pieces of information there. The top number 17 is your atomic number, that's the number of protons. And the bottom number 35.453 is the atomic mass. I would say the most common answer is usually answer B. B is incorrect in this case because that number, the atomic mass, is an average. It's an average of all the isotope masses. Remember, the mass of an individual atom is a whole number, 35, 36, 37, something along those lines. Okay, it cannot be a decimal. That is an average. So there is no chlorine atom out there that is 35.453. That is not a real thing. Okay, so it's a very common misconception that students make on this question. In fact, with the information given to us on the periodic table, there is no way to predict the number of neutrons. So while yes, A, C, and D are correct in the fact that they all have the same number of protons, 17, which is the atomic number, there's no way, based on the information we have in the periodic table, that we can predict the number of neutrons. So actually, all 3 answer choices are incorrect because there is no way that you can predict the number of neutrons based on the information from the periodic table. Now, if they had said this is chlorine 35 or chlorine 36 or chlorine 37, we could have figured out exactly how many neutrons there are. But since they didn't say that, we have to put E as none of the above. So remember, don't pick atomic mass if they ask you about anything other than it being either your atomic mass or the average of all the isotopes. Speaking of atomic mass, let's remember how to calculate that. Flip back to page 22. Question number 4, I'll give you another 10 seconds. All right, hopefully you guys are done with that. All right, so here, if we read the question, scientists have discovered a new element which they have named yesprepium. There are 3 known isotopes of yesprepium, 93%, and the element has a mass of 121 atomic mass units, or AMUs. 6.4% of the element has a mass of 122 atomic mass units, and the remaining 0.6% has a mass of 123 atomic mass units. What atomic mass should be printed on the periodic table? So this is a classic question where they give you some fake element with fake data and you have to calculate the atomic mass. Remember, the atomic mass is nothing more than an average of all this information. We can see here that our most abundant isotope by far is yesprepium 121. So if we look at the answer choices, we should pick something close to 121 because since most of it is made up of 121, that's going to be closest to the average atomic mass. So this is the actual formula for atomic mass. We have %1 times mass 1 plus %2 times mass 2 plus %3 times mass 3, and go on and so forth. And however many isotopes there are, you can continue to add them together and average them out. Remember, when you're calculating, you need to convert all the percentages to decimals in order for this to work. Okay, so that means that 93 is going to become 0.93, and 6.4 becomes 0.064. And then 0.6 becomes 0.006. Especially watch out for that last one. A lot of students would not have converted that, and they would have multiplied, and they might have got a wrong answer. Okay, so when we compute this, we put it into our calculator, we get the atomic mass is equal to 121.08 grams per mole. Notice that is not very different from the 121 atomic mass units that we were given in the information. A lot of the times, you can save yourself a lot of time from calculating this if you just figure out which isotope is the most abundant and you pick the answer choice that is closest to that. We could have known that it's not going to be exactly 121 because we had this other information, but it's pretty darn close to 121. It's a little bit heavier than that because 121 is so abundant. So remember that. If it's most abundant, you can just pick the one that it's closest to. These 2 answer choices are made for math errors. If you forgot to convert to decimals, that's the numbers you would get. So remember that one as well. Okay, you guys have plenty of time in Miss Lewis's class today. I have provided with her a key. So work on pages 22 and 25 for more practice of these types of problems. If you would like to work on the gas law stuff or the electron configuration stuff that we worked on last week, I'll provide the key for her for that as well. All right, please work hard, spend this time wisely. I know you guys are going to do great, so just do your best. All right, I will see you in chemistry if I haven't already seen you today. Take care.